A warm welcome to this video. This is G. Jayapriya, working as Assistant Professor in PG and Research Department of Chemistry, Sita Lakshmi Ramasamy College. In this video, we are going to discuss about commercial polymers. The topics to be covered in this video are definition of commercial polymers with the example, preparation properties and uses of polyethylene, preparation properties and uses of polyvinyl chloride, preparation properties and uses of polystyrene, which helps the students to understand from concepts to examples and practical applications. We are going to see the definition of commercial polymers. Commercial polymers are the polymers that are synthesized by chemical modification of naturally occurring polymers. They are produced industrially on a large scale for various applications. Examples include polyethylene, polyvinyl chloride, and polystyrene. These polymers are synthetic. It may originate from natural raw materials like hydrocarbons. First, we are going to see the preparation of polyethylene. Polyethylene is produced through the polymerization of ethylene using a different catalysis and condition. So here, ethylene is the monomer molecule which polymerizes to give polyethylene polymer. Here I gave you the structure of ethylene which polymerizes to give the polyethylene molecule. Polyethylene is of two types. First one is low density polyethylene and next one is high density polyethylene. Low density polyethylene is produced via free radical polymerization at high pressure and temperature. The pressure is about 1000 to 3000 atmospheric pressure and the temperature is about 200 to 300 degrees Celsius. These polymers forms a branched structure which make it flexible and less dense. And next is the high density polyethylene. This is produced by Ziegler-Natta or metallocene catalyst under very low pressure, which is about 1 to 50 atmospheric pressure, and moderate temperature is about 50 to 150 degrees Celsius. This polymer forms linear chain, making it more stronger and more rigid. I gave you the structure of high density polyethylene and low density polyethylene. Here you can see high density polyethylene have only linear chains, whereas in LDPE it has branched chains. Next, we are going to see the properties of low density polyethylene and high density polyethylene. Low density polyethylene is very much flexible, soft and lightweight. It has a melting point of about 110 to 115 degrees Celsius. It is highly resistant to moisture and chemicals. It is transparent and slight waxy. Whereas high density polyethylene is very strong, rigid and impact resistance. It has a high melting point of about 130 to 135 degrees Celsius. It has a good chemical and moisture resistance. It is opaque and durable. Low density polyethylene are used in making plastic bags, cling wraps and squeeze bottles. It is also used in making flexible containers and packaging films. Also used as insulation for electrical wires. Whereas high density polyethylene is used in making milk bottles, detergent containers and water pipes. It is also used in making crates, bins and toys. It is also used in the manufacture of fuel tanks and automotive parts. Next, we are going to see about polyvinyl chloride. Polyvinyl chloride is the most important commercial polymer. Preparation of polyvinyl chloride is produced through the polymerization of vinyl chloride monomer using different methods. The most common method is the suspension polymerization. By this method, vinyl chloride monomer is dispersed in water with an initiator. Polymerization occurs, which forms a small PVC particles. The final product is dried into powder or granules. Next one is the emulsion polymerization, which produces the finer particles used in a coating and films. And the third one is the bulk or a mass polymerization, which produces high purity PVC with uniform properties. Here I gave you the monomer of polyvinyl chloride, which reacts in the presence of paracids and atmospheric pressure, gives you the polymer polyvinyl chloride. PVC exists in two primary forms. One is rigid PVC or unplasticized PVC. and another one is flexible PVC or plasticized PVC. So rigid PVC are very hard, strong and durable. They are very much resistant to chemical, waters and UV radiation. They are self-extinguishing, which act as a fire resistant. Whereas flexible PVC are soft and flexible due to the plasticizers. The example for plasticizer are the phthalates. It has a good elasticity and impact resistant. It is also resistant to oil and chemicals. Rigid PVC are used in the manufacture of pipes, fittings and window frames. It is also used in making a credit cards and automotive parts. It is also used in making medical tubing and blood bags without plasticizers. Flexible PVC are used in making a electric cable insulation, also flooring, synthetic leather and waterproofing cloth. It is also used in the manufacture of flexible hoses and inflatable products. Teflon is also a commercial polymer. The monomer present in the Teflon is tetrafluoroethylene. Teflon is prepared by polymerizing tetrafluoroethylene at 30 to 40 degrees Celsius under pressure in the presence of acetyl peroxide as a free radical catalyst. Here I gave you the monomer of tetrafluoroethylene. In the presence of acetyl peroxide, it polymerizes to give a Teflon, which is a polymer. The properties of Teflon includes they are inert to most chemical acids and solvent. The melting point of Teflon is around 327 degrees Celsius, which allow it to use at a higher temperature. They remain very stable over a wide range of temperature about minus 200 degrees Celsius to plus 260 degrees Celsius. They have excellent dielectric properties which makes it used in insulator in cables and circuits. They are very much resistant to combustion. They have a self-extinguishing property. They are very much safe to use in medical and food applications. Now we are going to see the applications of Teflon. Due to extreme inertness of stability to temperature, Teflon is used in making gaskets which are subjected to high temperature. It can also form non-stick coatings. It is also used to coat the pot and pans. It is also used in coating glass fiber, asbestos fiber and cloths. Also, it is used as an electrical insulator, which is used for insulating motor, cable, transformers, etc. Teflon can dissolve a large quantities of oxygen and hence it is used in the replacement of valves in heart surgeries. Hope you all have understood the preparation properties and uses of the most important commercial polymers, namely polyethylene, polyvinyl chloride and Teflon. Thanks for watching this video.